Welcome to another coding tutorial, and in today's video, I'm going to show you how to create this effect while learning the basics of particle systems. So what is a particle system? The term particle system was first coined in the creation of this particular scene in the film Star Trek II, The Wrath of Khan in 1982. William T. Reeves, who's a researcher at Lucasfilm, described it as this. A particle system is a collection of many minute particles that together represent a fuzzy object. Over a period of time, particles are generated into a system, move and change from within the system, and die from the system. It is a very powerful and commonly used technique in simulating a lot of effects within computer graphics. And in today's video, I'm going to show you the key steps in creating a simple particle system. We'll start by creating just one single particle, and then a system of particles, or a particle system, and then we'll end the video by creating systems of particle systems to create the effect that you saw at the beginning. I'm going to start by defining a variable called position, let pos, and then this is going to be the position of a single particle. And I'm going to set this position as a vector. And a vector is an object that can hold 2 to 3 values, but we're going to use it to hold 2 values, which is the x and y coordinate of the location of a particle. So we can use a method within this class called createVector to create a new object. Actually, I'm going to put this inside the setup function. And then we're going to put it in the middle of the canvas, so width divided by 2 and height divided by 2. And then inside draw, I'm going to draw a circle using an ellipse function, which takes in a total of 4 arguments. The first 2 are the x and y coordinate of the center of the circle. So we're going to get the x position of the position vector and the y position of the position vector. Then how about we give it a size of 10? Alright, so nothing too exciting right now. We have a particle that is in the shape of a circle in the middle of the canvas. But next, how about we define a variable called vel, and vel is shortened for velocity, which is the speed and direction of this particle. And it is also going to be a vector, and I'm going to create it the same exact way. How about we give it a value of 1, 0, so it has a speed of 1 in the positive x direction. And we want to update the position by adding the velocity, right? So we can do that by using a method called add, and then we put in vel. And what this does is that we're basically adding the x and y component of the velocity vector to the x and y component of the position vector. So 1 will be added to width divided by 2, and 0 will be added to height divided by 2 over time. So if we click run, then it moves to the right. So how about we make it a little bit more exciting? So I'm going to give it a random value between -1 and 1 in both the x and y direction. So now every time I click run, the particle moves in a random direction at a speed of 1. And exactly what I wrote right here, I can use this method within the vector class called p5.vector.random2d. And this method here basically does the same thing that we just did by returning a random vector with a magnitude of 1. So if I click run, you get the exact same thing. But now the particle is moving at a constant speed. But if we want to actually change the speed over time, we can add another variable called acceleration. Let's shorten it as ACC. And how about we first actually define ACC as this random vector, and then we're going to initialize the vector at 0, 0. And now what we want to do is that we want to also update the velocity vector with the acceleration vector. Actually, I'm going to start at 1 just to show you first what it does. You see that? The particle is moving to the right, but the speed increases over time. So how about we also randomize the speed here by using the random2d function. And because this random 2D function gives a magnitude of this vector equals to 1. The particle is moving kind of fast. What I want to do is I want to slow it down a little bit, and I can do that by basically multiplying the acceleration vector by an amount. So let's say I do it by 0.05. So the acceleration value here, which returns a magnitude of 1, now is decreased down to 0.05. So it still speeds up, but at a smaller magnitude. So now we have the basic of a single particle. So how about we put it inside a class? So let's come to this arrow here, click create file, and then I'm going to call this file particle.js. And then before we start writing the class, let's go to index.html, come to this line of code here, copy and paste, and we want to change the name sketch here to the name of our new file, particle.js, and this is how we integrate a new JavaScript file into the program. All right, so let's go back to particle.js. Let's start by writing the word class. I'm going to call this class particle, and then inside the constructor function, I will need the position, velocity, and acceleration, right? So I need all of this. All right, and then make sure to put in this dot. Then instead of defining width divided by 2 and height divided by 2 here, why don't we give it x and y as the parameter here? All right, so the next method is update, and it's basically is going to be these two equations here where we update the position and the velocity, right? So this .vel, .add, and then same thing for this .post, this .vel here. And then we'll write one more method called display, and we're going to draw this ellipse here. All right, so how about we just create one particle object? Let's call it P, and P is going to be a new particle object, and let's put it in the middle of the canvas again. Then we're going to call update, and we're going to call display. All right, so nothing new, everything's the same, but now it's part of an object. Now we want to create a system of particles, so we need more particles. So how about I set this as an array called particles, and then what we want to do is inside the draw function, I'm going to add a new particle every time the draw function is called. And we can do that using the name of the array and then the push method. And we want to push what? We want to push new particles inside here. All right. And then after that, we need to call update and display on all of the particles object, right? So we can use a for loop. So for let I equals to 0, I less than particles dot length, and the length is going to change over time, right? It's going to increase over time as we add more and more particle objects inside the particles array. And then we want to do particles of I. Same thing here. All right. Okay, let's see. All right, so now we have a particle system, but let me show you something. So if I print particles.length, so as you imagine, the length of the particles array increases over time, right? Because we keep pushing a particle object every time the draw function is called. Even though the particle is already off the screen, it is still inside this particles array. But we don't want that. What we want to do is that we want to remove an object that is already off the screen or with a certain specific condition. And I'm going to create a new variable called life. Let's set it at 255. And this is going to be the alpha value that we give inside the fill function. So how about we color it red, and we just set this .life here. And then inside update, what we want to do is that we want to decrement it by a certain amount. How about we decrement it by 5? So let's click run. All right, so as you can see, the alpha value for a lot of these particles are already less than 0, right? We haven't done anything to the length of the array yet, but this is how we will use as a condition to remove a particle object from the array. All right, so now how about we write a new method and let's call it finished. And then we're going to write a conditional statement that says if this.life is less than 0, right? Meaning that the alpha value of those particles is transparent now, is less than 0. Then we want to set a Boolean variable called this.done to be equals to true, and then else this.done will be false. And then we want to also set this.done to be initially false, right? Then we want to call this finished method inside update, and we can do that by using this.finished, and this is how we called a method inside a class. We use the word this dot, and this is going to tell us whether this.done is true or false. Then now inside sketch.js, what we want to do is here we want to write a conditional statement that says if this.done is equal to true, right? Oh, not this.done, it's particles of i.done. Then we want to remove an object from the array, and we can use a method called splice. So we can put in the name of the array and then the method called splice. And splice can take in arguments in a few different ways. The way that we're going to do is by providing 2 arguments. The first one is the index of the object that we want to remove, which is the index I. And then the second one is the number of objects that we want to remove. By putting in 1, it's basically just removing the object at the index I. So let's click run. So it does fix the length problem here of the particles that are has the life that is less than 0, right, are being removed. But as you can see here, do you see this flickering thing happening right now? And the reason that we're getting that flickering issue is because of the way we are using the for loop. So right now we're using the for loop that loops forward. Let's say that we have an array of size 5. And we're going to the for loop to check whether that object is done or not. And so when I equals to 0, it's fine. I equals to 1, it's fine. But then when I equals to 2, that object is done and we want to remove it. So we use the splice function to remove that. But what is happening is that the objects are in the positions to the right of the ones being removed get moved to the left. So now the object that was previously in I equals to 3 then gets moved to the position of I equals to 2. So inside the for loop, we're going to I equals to 3 now. So the object that previously was in that position will be skipped, so it's never get checked, and that causes the flickering issue that you saw. So what we can do to fix this issue is that instead of looping it forward, we can do it backwards, right? So what we want to do is that we want to start from I equals to the length of the array minus 1, and then we do it backwards. And this way, when an object gets removed and everything to the right gets shifted to the left, none of the objects now will be skipped. So we want to change from this forward loop to a backward loop. So let's do I equals to particles dot length minus 1. And then this condition will be greater or equals to 0. We want to do minus minus here. Then let's click run. And so the flickering issue is not there now. Now that we have a particle system, I want to show you how to create systems of particles. Instead of pushing a new particle object inside this particles array every time the draw function is called, what I want to do is I want to set a new variable called num and give it a number of particles that I want inside my particles array. And then what I want to do is actually, how about we write a function called mouse clicked. This is actually a built-in function that basically gets called every time we click the mouse. So what we want to do is we want to write a for loop that goes through I equals to 0 to I less than num, I plus plus. Then we're basically going to push this set number, right, 50, and we want to push it at the location where click the mouse. All right, let's click run. So now this is one particle system every time I click the mouse. Perfect. All right, so now how about we write another class, let's call it system. We're going to do the same thing. Let's call this file system.js. Don't forget to add it to our index.html. All right, system. And then I'm going to call this class system. And inside the constructor function, I basically only need two variables, two parameters here, x and y, which is going to be the location of where we want to start the system, right? Then how about we write two more? One is update and one is display. Oh, and what we need here is we basically just need this whole thing, right? To create just one system of particles. So we need a particles array and we need the number. So let's go to system.js. So we need this.particles, which is going to be an array, and then we want this.num. Then also inside the constructor function, we also want to create new particles objects, right? Here, we're using a for loop, and this for loop is going through I equals to 0 to I less than num, and then we're going to push a new particle object. Where? Not at mouse x and mouse y, but at this.x and this.y. And as you can see here, we can create new object of a different class, right, inside another class. All right, so inside update, we want to, what? We want to basically just call the update function, right? And we want to call this done. So let's copy and paste this also. All right, so this has to be this dot. I'm actually going to delete this display for now because I want it to be part of the display method. Then this dot. Then inside display, we can just go through the particles array, and we can do it in the forward way this time now because the splice function is inside update. And now it's going to be this dot particles of I dot display. All right, so let's go back to sketch.js. We don't need this mouse click. And how about we just create one particle system? And it's going to be a new object of the system class. And how about we put it at width divided by 2 and height divided by 2? And then we're going to call ps.update and ps.display. What is it? Particles is not defined. Oh, this dot particles. All right. All right, now let's create multiple systems of particle systems. We'll set this as an array. And then how about we just do the mouse click function again. And then we're going to push it every time we click the mouse. So ps.push new system. We want to push it at mouse x and mouse y. And then here we want to loop through the length of the particle system array, right? And then we want to call update and display method. Click, 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 click. So what's the issue here? It's the same exact issue, right? Which is what? Let's print the length of this array. 1, 2, 3, 4, 5. It's gone, but the length keeps increasing. So we want to do the exact same thing, which is we want to remove the system inside this particle system array that is no longer on the screen. So we can do that by, first, how about we write, let's call it finished, and we say that if what? We want to check if the particles array has the length of 0, right? So there's no more, all of those particles are being removed. Then we want to say that this particle system is done. So if this dot particles dot length is equals to 0, then this dot done equals to true. Else this dot done is false. And then inside update here, we're going to call the finished method, right? And then we also need to set this dot done variable, set it to false. Then inside sketch.js here, we want to first loop it backwards, right? So let's do I equals to ps dot length minus 1. If I is more than or equals to 0, let's decrement it by 1. And then we're going to write a conditional statement that says if ps of I dot done is equals to true, then let's remove it. So splice I comma 1. All right, let's also print ps dot length here. Click run. Yay! You see? It goes back to 0 when everything's gone. So instead of clicking the mouse here, what if inside here, what I want to do is I want to call a random function, and random function without giving an argument here, it will give us a value between 0 and 1, not including 1. And we can use this and set it to less than a value. Let's do 0.3 to actually not create a particle system every time the draw function is called, but only create a particle system object when the random value here is less than 0.3. We want to push this, and then we want to push it. Let's do it in the middle of the canvas. All right, so that's pretty cool. So I'm just showing you a different way of creating particle systems on the sketch, where at the end here, I want to tweak a little bit here and there to create the effect that I want. So first, I'm going to go to my particle.js file here. I want the size of the circles to be 2. And then I also want no stroke. And I actually want to not only set the value of the color to be red, I actually want to set a new color mode. Instead of the RGB mode, we're going to set the color mode to be HSB. I'm going to give it a second argument of 255, which gives it a range between 0 and 255. And HSB is another color mode, stands for hue, saturation, and brightness. And now we cannot just use this .life as part of the alpha value anymore. I'm actually going to replace it for the brightness. So as we decrease the life variable here to be less than 0, so the brightness basically goes from white to black. So what I'm going to do is I'm going to give a new variable. Let's call it hue value, start it at 0, and then inside update here, I want to increment the hue value over time by 1. And I want to also write a conditional statement that says if this .hue value is greater than 255, which was the range that I set initially, right? Then I want to return it back to 0. And then now we want to give this hue value as the first argument inside the fill function. The second one is saturation, which I'm going to give it at 255, which is the maximum. And then this .life, which is brightness, which starts out at 255 and will be decremented over time. And let's click run. All right, so as you can see here, it turns black at the end here. So I want to also actually set my background to black so that it seems like it just disappeared. All right, and then you can tweak, let's say you want to tweak this decrement here, or you can tweak the acceleration value, right? So this just gives you a different effect. What if we randomize this value here? Instead of getting this circle thing, we'll get a little bit more random look. Which looks kind of neat. I actually want to put it back to the same thing, but what I'm gonna do now is, instead of actually pushing a new particle system object inside this conditional statement, I want to set a new conditional statement that says, if the location of my mouse previously and my mouse now is different, then I want to add a new particle system object. So we can do that by using the built-in function called p mouse x minus mouse x. And this value can be both negative and positive, and I want it to be just positive. So let's use a function called absolute abs here. If this is greater than 0, which means that I move the mouse, right, in the x direction, or abs of p mouse y minus mouse y is also greater than 0, then that means I move the mouse. Then I want to add a new particle system object, actually at the mouse x and mouse y location. Let's try it. And look at that. You get this magic wand effect. I hope that you enjoyed this video because particle systems is a very basic concept but actually very powerful. As you build one thing on top of each other, you can create a very visually engaging effect. So give this one a try.